Good morning, year nines. I'm Mr. Vincent. Hope you're all well and staying safe. Today, we're going to continue with a series of lessons on how to use physics equations effectively. And for this particular lesson, we're going to look at the equations for power. I suggest at this point that you pause the video, make sure you've got all your writing equipment, that a pen, pencil, ruler, a paper, your calculator, and also just get ready to do the starter task. Please pause the video now and collect your equipment and go through the starter task. Let's go through these starter questions quickly. I have provided you with these 5 questions because these 5 equations are equations you need to be able to recall and apply in an exam. They will not be given to you in an exam. I want to point out that last Monday you studied an equation for elastic potential energy with Mr. Shannon. That equation will be given to you in the exam. What you need to be able to do is to know when to use it and how to rearrange it. But it will be given to you in an exam. Unlike these 5 on here, they will not be given to you in an exam. So please make sure you study them. They're quite important. Write the equation that links gravitational field strength, weight, and mass. The equation that links those 3 quantities is W equals mg, that is the symbol form of the equation, or you write the word equation, which is weight equals mass multiplied by gravitational field strength. The second question is to write the equation for calculating pressure. Pressure equals force divided by area, or you can write the symbol form P equals F divided by A. The next equation was to write the equation that links distance traveled, speed, and time. And you could use speed equals distance divided by time, or distance traveled equals speed times time. Or you could have also written time equals distance divided by speed. Any of those 3 forms is perfect, it's fine. Now, the fourth question is to write the equation for calculating gravitational potential energy. E subscript P equals mgh, that's the symbol form. And number 5, write the equation for calculating kinetic energy. E subscript K equals half mv squared, or you could say E subscript K equals 0.5 multiplied by m multiplied by v squared. Hope you had all of these equations correct. I just want to let you know that by the end of this term, you would have learned 9 out of the 22 equations you're meant to be able to recall and apply in the AQA exams. With these 5 on the screen, plus 2 which is studied with Mr. Shannon just before the Easter break on energy efficiency, and then the 2 we're going to study today on power. That will make a total of 9 out of 22, almost half the number of equations you're meant to study for your AQA exams. So please, if you haven't studied the lesson and gone through the quiz on energy efficiency, which was posted before the Easter break, I suggest after finishing this course, this unit, you go back and look at that lesson and go through the quiz so that you can learn the equations for energy efficiency. Okay, let's move on. Today we're going to be talking about power. We want to look at what is power and how power is linked to work done and energy transferred. We're going to look at the 2 equations for calculating power. Thirdly, we're going to be able to rearrange those equations and apply them as we will go through questions. And finally, writing the standard SI unit for power. So, what is power? Power can be defined as the rate at which energy is transferred. We use the word rate because we want to say how quickly energy is transferred. So take, for instance, appliances at home. We have a kettle which has 1500 watts as its power rating. That simply means that the kettle transfers 1500 joules of energy every second. Let's compare this with another kettle that has a power rating of 1000 watts. What it simply means is that the kettle with a power rating of 1500 watts is more powerful than the kettle with 1000 watts. How or why do we say that? We say this because for the same volume of water, or probably the same mass of water, if we want to use that word, poured into each kettle, the kettle with 1500 watts will raise the temperature of that water to boiling point quicker than the kettle with 1000 watts. So we say the kettle with 1500 watts is more powerful than the kettle with 1000 watts. Of course, the unit of power is the watts, WTTS, or you can say joules per second. And I'll explain that further when we start using the equations for calculating power. At this point, I'll ask you to complete this mini task. Go around your house, read the power rating of the appliances or gadgets that you have at home. The label with the power rating will be something like this, and you'll see one of the numbers with a W at the end. For instance, on here, this food steamer has a power rating of 900 watts. It simply means 900 joules of energy is transferred every second this appliance is turned on. So you can do it and try explaining what the power rating means to your parents or your brothers and sisters or your carers. Okay, let's move on. Now, the second definition of power. Power can also be defined as the rate at which work is done. Again, rate means how quickly work is done. So let's take an example. We have two power lifters on here. I am now assuming on here that they're lifting the same weight to the same height. If you look at the photographs carefully, you see that the weightlifter on the left hand side is quicker, lifting his weight quicker or faster than the one on the right. Hence, I will say the weightlifter on the left is more powerful than the weightlifter on the right. Now, let's look at two words which we've used to define power. The first word we want to look at is work. What is work? Work is the measure of the energy transferred when a force moves an object through a distance. So work involves force and distance. So we take, for example, a book pushed along the table from one end of the table to the other. Work is done because a force is applied to move the book along the table and to overcome friction and the book's weight. A force needs to be applied to do that. So when work is done, energy has been transferred from one energy store to another. So energy transferred is equal to work done. Now, in this example, the chemical energy in your muscles, which you've got from your food and oxygen, is transferred to kinetic energy to move the book along the table. So energy is transferred from your muscle, chemical energy in your muscle, to kinetic energy. So energy transferred and work done are both measured in joules. Now let's discuss energy. Energy is a difficult concept to explain, so I'll leave you with three statements regarding energy. Energy does not make things happen. Forces make things happen. And when we talk about forces, we mean push or pull, compression or stretching. That's what we mean about forces. Now, when forces make things happen, energy is transferred. So energy is transferred from one store to the other. If you raise an object from ground level and put it on top of a shelf, the object will now have gained gravitational potential energy. Of course, that would have happened because you use your muscles, which has chemical energy in it, to lift the object to put it on the shelf. Now, the sort of thing is energy does not explain why anything happens or how it happens. Only physical processes tells us this. We have two definitions for power. Power is the rate at which energy is transferred, or power is the rate at which work is done. Hence, we have two equations for calculating power. The first equation for calculating power is power equals energy transferred divided by time. Okay, and so symbol form power, the unit of power is watts. That's why we have a W here. The unit of energy is in joules, and then time in seconds. Now, the next definition for power equals work done divided by time. W, power P, watts W, work done W, its units is in joules, and divided by time T in seconds. So these are the two equations for calculating power. You will notice when you compare both equations that we've simply interchanged the words, replaced energy transferred by work done. So let's take an example. The toaster transferred 108,000 joules of energy in 2 minutes. What is the power of the toaster? We've given the energy transferred from the question. We've given the time. The first thing we do, we write down the equation, the main equation. Power equals energy transferred divided by time taken. Now, the power we don't know, that's what we have to calculate. Energy transferred is 108,000 joules. Time is 2 minutes. But we're told in a formula the time should be in seconds. So we converted 2 minutes to seconds by multiplying by 60. Then we substitute into our equation P equals 108,000 divided by 120 seconds. And the answer is 900 watts. So the toaster has a power rating of 900 watts. Okay, here's a question for you to practice. It says a weightlifter used 300 joules of energy to lift a dumbbell for 0.5 seconds. Calculate the weightlifter's power output. Please pause the video now and attempt this question. Okay, let's go through the question together. Write down a formula first of all. We look at the quantities given. We're given the energy transferred 300 joules. We're given the time 0.5 seconds. We simply substitute those two numbers into our equation, and the answer is 600 watts. That is the power the weightlifter has. Now let's rearrange this equation. Assume you're given a question in which you have the power, you're given the time, you're asked to find the energy transferred. So let's make E the subject of the formula. We write a standard equation down. P equals E over T, power equals energy transferred over time, symbol form. We want E alone on one side of the equation. But now we've got T in the denominator with the E, so we need to get rid of the T. Since the T is in the denominator, we multiply both sides by T so that we'll be able to cancel out the T's on the right. Right. So now we've got T on the right hand side, we've got T in the numerator and T in the denominator. These two T's will cancel out. So then we are left with P times T equals E. We just rewrite the equation such that the E is on the left hand side, so it's E equals PT. Again, I'm not going to go through the same process. We're just replacing the E by W for work done, and that will be the same equation, W equals PT. Whether you're given energy transferred or you're given the work done in joules, it is the same equation you use. Either if it's energy transferred, you use E equals PT. If they use the word work done, use W equal PT. Energy transferred equals work done. Right, let's take an example. An electric kettle is rated at 2 kilowatts. Kilo means multiplied by 1,000, so that is 2,000 watts. How much energy is transferred in 30 seconds? So, From the equation, we write down a standard equation. From the question now, we find our values. We're given the power, 1000 watts. We're given the time, 30 seconds. We have to find the energy, E. We rearrange the equation until we get to E equals P times T. Substituting to the equation, we get E equals 2000 multiplied by 30. So 60,000 joules of energy was transferred in 30 seconds. Okay, here's a question for you to practice. Please pause the video now and have a go at this question. So the question says, calculate the chemical energy used by a car of power 25,000 watts in 50 seconds. First thing, we write down an equation. We look at the quantities given to us in the question. We're given a power, 25,000 watts. We're given time, 50 seconds. We have to find the energy. We arrange the equation until we get E equals P times T. Substitute into the equation, and we get 1,250,000 joules of energy. Hope you had that correct. Now let's take the third rearranging of this equation, and this time around we're going to rearrange the equation to make time the subject of the formula. So you might be given a question wherein the power is provided, the energy transferred is given to you in the question, and you have to find for how long was this equipment on. We write down a standard equation, P equals E divided by T. This time around, we have T in the denominator. Number one, we'll need to get T to the numerator, and number two, T has to be alone on one side. So, to get T to the numerator, we multiply both sides by T. We will notice from the right-hand side that we have T in the numerator, T in the denominator, the T's cancel out. So we're left with P times T equals E. Now, we just divide both sides by P because we want T alone on one side. T is next to the P. We don't want the P here. We want the P to be on the other side. So we divide both sides by P. Dividing both sides by P, we will notice that on the left-hand side, there's P in the numerator, P in the denominator. The P's cancel out. And so we're left with P equals E over P. And if we replace the E with a W for work done, we have P equals W over P. That is how you make time the subject of the formula. Let's take an example. It says, how long does it take an aeroplane of power 900,000 watts to use 2,700,000 joules of energy? Again, we write a formula down, P equals energy transferred over time taken. We asked to find how long, we asked to find the time. So power is 900,000 watts, energy is 2,700,000 joules. Substituting into our equation, and we got time equals 3 seconds. So that's how long it will take the plane with a power of 900,000 watts to use 2.7 million joules of energy. Okay, here's a question for you to practice. Please pause the video at this point and go through this question. Okay, now let's go through the questions together. We asked to find the time. We're given the power 40 watts. We're given the energy transferred 80 joules. Substituting into our equation and rearranging our equation, we have 80 divided by 40. So we have 2 seconds as the time. Here are 3 practice questions for you to try out. Please pause the video and go through them. Okay, let's go through the practice questions together. First one is a crane is used to lift heavy building materials on a building site. One crane transfers 20,000 joules of gravitational potential energy to the building materials in 16 seconds. Calculate the useful power output of the crane. Again, we write our equation, power equals energy transferred divided by time. We're given the energy transferred as 20,000 joules. We're given the time as 16 seconds. Substituting into our equation, we get 1,200 watts. So that is our answer. Hope you got that correct. Let's take the next one. Right. The next question says an energy efficient light bulb has a power rating of 7 watts. Calculate the amount of energy transferred in 2 hours. So, energy equals power times time. The equation has already been rearranged for you, but in the exams, you can write the original equation, substitute into the equation, then rearrange it to get to this point and do your calculation. So, we have energy equals power times time. We substitute our values. We know power is 7 watts, the time is 2 hours, but you got to convert 2 hours to seconds. We cannot work in hours. Remember, the other way of writing watts is joules per second. So your time has to be in seconds. And it is 60 seconds make 1 minute, 60 minutes make 1 hour. You multiply the two 60s together, we got 3,600. So 3,600 multiplied by 2 is what gives us 7,200 seconds. Now we can make a substitution in the formula and solve, and that is our answer. The energy transferred is 50,400 joules. Hope you had that correct. You remembered to convert your 2 hours to seconds. The third question we're going to look at is professional cyclists can produce a steady power output of 240 watts. Calculate the time taken for the cyclist to transfer 30,000 joules of energy. Then we write the main equation, we rearrange the equation and get to the point where we have time equals E divided by P. We substitute our values into the equation, energy 30,000 joules, power 240 watts, do the division, and we have time is 125 seconds. Please don't convert to minutes if you are not asked to do so, because you might lose marks if you make an attempt to convert it and the conversion is wrong. You will lose marks for that. So just leave your time as 125 seconds. There are 3 more practice questions for you to go through to make sure we understand this topic. Please pause the video now and attempt these 3. Okay, let's continue. Let's look at these 3 questions quickly. This first question, I'll only display the answers quickly for you to check your work. Two things here I want to point out that the power was in kilowatts. You have to multiply by 1,000. The time given to you was 30 minutes. You're going to multiply by 60 to convert to seconds, so you get 1,800 seconds. Then you substitute into your equation and get the answer of 9 million joules, which can also be written as 9 megajoules. 10 to the power 6 is mega, 10 to the power 3 is kilo. Please note those conversion units. Right, the second question is the kettle transfers 180,000 joules of electrical energy in 115 seconds. Calculate the power rating of the kettle. Then we use a standard equation. Power equals energy transfer divided by time. We're given the energy, we're given the time. Simply substitute into the equation and we get 1,565 watts. Right. Last one, it is an energy efficient light bulb has a power rating of 6 watts. Calculate how long the light bulb was left on for if 12,000 joules of energy was transferred. So we're given energy, we're given power, we are asked to find time. We arrange the equation up to the point time equals energy transfer divided by power. Make our substitution and our answer should be 2,000 seconds. Again, except you're asked to give your answers in minutes, do not convert the time. Just leave it as it is, you'll get your marks. If you attempt to convert it and you miss the answer, you may lose marks. Right, 3 practice questions for you to try out again. Please go through them and make sure you understand the concept. Please pause the video now. Right, we have now completed this topic. So, if you understand the concept, then move on to completing the quiz. If you have found the concept a bit challenging, I suggest you go through this video again until you're confident you've understood this topic. Remember, the 2 equations we've talked about in this topic are equations you should be able to recall, rearrange, and apply in an exam. Thank you.